Hello and welcome to this lecture where we are going to finish the implementation. The first step is to create user query st.chat_input. Enter your message here. Then we need to verify if user query is not none and user query different from empty. We need to check if the user has filled in the text box, and we need another verification. And uploads is not none. So we need to guarantee that the user has uploaded some files. If this condition is true, we are going to access the session chat history session variable dot append human message, and the content of the message is user query, the text provided by the user. Now we need a similar verification we implemented in the other project. Chat message human, then we are going to use markdown function user query in order to show it in the web interface. Then we need a similar code with st chat message. If it is a message sent by the artificial intelligence, we are going to run all the code to perform the operations. If st session state, we are going to verify docs list variable. This one we have implemented here. At the beginning, it is initialized with none. We are going to see if the session variable is different from uploads. Just a reminder that uploads is the file uploader. We need to guarantee that the list of documents is equal to the uploads, in the case the user uploads new files while executing the chatbot. When this condition is true, we need to update session state docs list needs to be equal to uploads. We are updating the session with the new files provided by the user, and we are going to access the other session variable retriever equals config retrieval, the function we created before, and we are going to send as parameter uploads. Retriever is this session variable we created here, and we can go up to this function config retrieval. We can just change the name config retriever. It receives as parameter the list of files and executes all the process of the RAG pipeline. Load the documents, split them, apply the embedding algorithm, store the data, and configure the retriever. When the user provides new files, we need to update the list of the documents as well as the retriever in order to store the new data. Then we need to create LangChain variable and call the function config LangChain. We are going to send model class as parameter st.sessionState.retriever. Just a reminder, this function was implemented here. It loads the model, set the prompts, the history-aware retriever, create and return the chain. After we load the chain, we can get the result. So we can call LangChain.invoke. And let's send as parameter input is the user query and also the chat history that is stored in the session variable st session state chat history. I'm going to create a new variable, the response. We are going to get the result and access only the answer key. Since the information is here, then we can write in the interface, write resp. This is the basic process. If you try to run this code, you will see that it might be working. But now let's implement some additional code in order to show the source, since the algorithm is going to generate the responses based on the files provided by the user. The idea is to print some parts of the text that was used to generate the answer. So I'm going to create a new variable, sources, result. We are going to access from this variable only the context, which are the PDF files. Now we need to go through idx doc in enumerate sources. We are going through all the sources, create source variable, doc metadata, get only the source, file, OS, path, base name, source. We are getting the name of the file. We also are going to get the page where the data is extracted. For example, in a 10-page PDF, we are going to show that the response was generated using, for example, page 3, page 4, page 5, and so on. Metadata dot get, let's get the page, and if the algorithm is not able to get the page, we are going to send this message, page not specified. In the next line of code, we are going to create the reference. We have a formattation in the format of a link. We are going to show the source, the name of the file, as well as the page. It will be easier to understand when we run the application. Now I'm going to create a popover. It is a stringlet component. Let's send ref st caption doc page content. We are going to show the content of the page. Let's just adjust this code. All this code is inside with statement. It is a message from the artificial intelligence. And after we have executed all the AI behavior, we are going to access session state dot chat history, append AI message, and the content will be the response. We are updating the history. And that's all for the implementation. Let's save the file. Just a reminder, it is not possible to run the file through this button. So now we need to call stringlet. Stringlet run and the name of the file, project3.py. Press enter. We have the message, please send some files to continue. So we are going to click on browse files, access the documents folder. You have access to this file, and there are two files. The first one, it is a fictitious company called Blue Nexus Industries. This company does not exist, so we are going to ask the algorithm to get information from this PDF file. As you can see, there are some pages about the company. Then we have this other file. Attention is all you need. It is the paper that covers the transformer architecture. So I'm going to select both files, click on Open. Now we are able to chat with our documents. Just to test if it is all working, I'm going to say hello. There is one error in recursive character text splitter. It is missing letter C, chunk size. I have corrected the code and see that it is running. The first execution can take some seconds since we are running all the indexing process. We have here the first result. It seems like you didn't ask a specific question, but I'm here to help. See that it already reads all the papers. If you are looking for information about Blue Nexus, I can tell you that it is a company that offers AI solutions. And here is the components we created in the implementation. We have the sources as well as a part of the text where the information was extracted. Now we can ask some questions. For example, tell us about the company Blue Nexus. We have here the response with a summary of the company. And here we can check the sources. Source 0, in this example, we are accessing the same PDF file. Page 0, page 3, and page 2. It is particularly useful when you have a lot of PDFs. So it is going to show the sources here. Let's ask another question. When was it founded? Was founded on March of 2015. Now we can see how the chat history works. Since we are using it, that refers to the Blue Nexus company. It is related to the history-aware retriever. If you don't use this technique, maybe the algorithm will not know how to reference the word it. Let's ask some other questions. What was the revenue last year? Here is the response. Let's ask another question. Who is Dr. Watson? Dr. Watson is the current CEO of Blue Nexus. Dr. Watson is also a character in the Sherlock Holmes series. Most algorithms would answer about the series if we hadn't added the context about the company. So the algorithm knows that we want information about the company. Now let's ask another question. What is attention? And here we have the response according to the other PDF file. Attention is all you need. According to the provided context, it refers to an attention mechanism. It is responding the question according to the context, and it is not responding it according to the general meaning of the word attention. That's all for this lecture that we have just finished implementing and testing this project. It is very interesting since you can use it by yourself with your own papers. I recommend that you browse some of your files and perform tests. In this execution, we are using Llama 3, but I encourage you to perform tests using ChatGPT and Phi 3 models. See you next time!